So what happens to the current rating? So what happens when there is a continuous flow of the current through the heater? The temperature basically increases. Okay, the temperature basically increases, and once the temperature increases, what happens? The resistance of the heater also increases. So I can write here. First of all, the resistance increases, resistance of the you can see resistance of the heater increases, and that's why now we can use the Ohm's law in the circuit. So V is equal to IR. That means I should be equal to V divided by R. Okay, and we know that the resistance is increasing because as the heater is becoming hot, the resistance of the heater generally increases. So if the resistance across the heater increases, we can use this formula. This formula is telling you current is inversely proportional to the resistance. That means if the resistance increases, current should decrease. So I can write here the current or electric current decreases. Okay, so current, what happens to the reading in the ammeter? It should decrease because the current decreases. Okay, because the potential difference across uh, the heater remains the constant. That's why I is inversely proportional to R. So if R is increasing, the current decreases. And why R increases? Because of the increase in the temperature in the heater. Okay, and why there is an increase in the temperature? Because the current continuously generates the heat. Okay, so I hope you understood this problem. Now we will move towards the next problem. Now the next problem in the structure problem. In this figure, 12-volt battery supplies the current of I here to the circuit. The circuit contains the thermistor and the 1000 ohm resistor in the parallel with 500 ohm resistor in the series. So first understand the circuit. You can see this is 12-volt battery. These are the two resistors. So first resistor, this is 1000 ohm resistor. This one is nothing but the thermistor. Okay, and those are connected in the parallel because there are the junctions. And this is another 500 ohm resistor which is connected in the series with this combination. This combination is a parallel combination because this parallel combination is in series with this 500 ohm resistor. So now at certain temperature the resistors has the resistance of 1000 ohm. Okay, we know what is the function of the thermistor. Thermistor is the resistor whose resistance increases or decreases when temperature changes. Okay, depending on type of thermistor, its resistance basically changes with the change in the temperature. Okay, we have learned this. So thermistor has the resistance of 1000 ohm. Now do not confuse with the another word it is used over here, that is the thermistor. You can directly assume this as a resistor because thermistor is nothing but the resistor. So directly consider this is the resistance value of 1000 ohm. Okay, that's it. The combined resistance of the thermistor and the 1000 ohm resistor. So what we are asking, the combined resistor of this. So this combined resistor of the 1000 ohm resistor and this thermistor. So thermistor, I already said, do not confuse with the another name. You can consider this as the another resistor only of the 1000 ohm resistance. So these two resistors are there. Both are 1000 ohm resistors and those are connected in the parallel, and we need to find out the total resistance. That's it. So whenever we have a series combination, we use this formula R1 plus R2. If there is a parallel combination, we use reciprocal of R. So R total is 1 by R1 plus 1 by R2. And if you basically do this reciprocate thing, that cross multiplication, then 1 by R total is equal to R1 plus R2 divided by R1 plus R1 into R2. So we have to use this second formula because our combination is basically nothing but the parallel combination. So I will use this formula here, and both our you can see both of the resistors are nothing but the parallel resistors. So I can use this formula. So this is nothing but equal to, I can write down over here, 1000 of this resistor and 1000 for the thermistor. Okay, both are having the same amount of the resistance, and you can use this. You have to divide this with the same value, that is 1000 multiplied by 1000. Now if you calculate this value using the calculator, you will get the answer of 0.0020. Okay, so upper part, the denominator, numerator is nothing but 2000, denominator is 1000 into 1000, that is 10 lakh or 10 raised to 6. So that is nothing but 0.002. Now this 0.002 is nothing but 1 by R total, okay, and we need to find out R total. That's why we have to reciprocate it. Okay, so I will write over here, the R total is basically, R total is basically equal to 1 divided by 0.002. That is coming out to be 500 ohm. That is coming out to be 500 ohm. Okay. So here you can say the R total is 1 divided by 0.002, because this is a reciprocal. 1 by R total is this. So R total is 1 divided by 0.002 ohm. Okay, so this one is the value of the combination of the resistor of 1000 ohm and the thermistor of the 1000 ohm, that is nothing but 500 ohm. So I hope you understood this. We have just done the calculation of the using this parallel combination. Okay, because this is in the parallel combination. Now we need to find out the current in the circuit. We need to find out the current in the circuit. That means this I value we need to find out. So to find out this I value, what we are going to do, we will consider this entire as our uh, combination of the resistances. Okay. We have already found the value of this combination. This combination value is nothing but 500 ohm. So I already told you this combination is in series with this 500 ohm. Okay. Is in series with this 500 ohm. That's why the addition of this with this 500 is nothing but our total combination, resistance of the total combination. So this is 500 plus this is 500. So total resistance, first of all, of the combination is nothing but the 1000, because we are now using this formula. R total is R1 plus R2. What is R1? R1 is entire this combination. Entire this combination is a 500. That is our R1. This is a R2, and both are in the series. So R total now, or we can find out simply the R of the entire. You can say entire circuit. Entire circuit R is nothing but 500 plus 500, that is coming out to be 1000 ohm. So the entire circuit resistance value, total resistance value will be 1000, and we need to find out the current, and we need to find out the current which is flowing through the entire circuit, basically from here to here, everywhere. And that's why to avoid this complexity, I have just considered this as a only one resistor of 1000 ohm. Now we can simply use the Ohm's law, because we know the power supply voltage, that is 12 volt. We know this entire combination is 1000 ohm. So we can use the simply the Ohm's law over here. So V is equal to IR, and here it gives I is equal to V divided by R, and the power supply is nothing but 12 volt divided by this 1000 ohm entire combination. So the value of the current is basically coming out to be 0.012 ampere. Okay, this is the value of the current. If you calculate this, 12 divided by 1000 is basically 0.012 ampere. So this we can write 0.012 ampere. That is the current flowing through the entire circuit. and there is no change in the current because it is a series circuit. If I consider the entire this as a one resistor,